evening, Bearcats. This is 1.3 linear equations in two variables, and those two variables, of course, would be your x and your y. We're talking about linear equations here. We're going to talk about slope and about writing equations of lines, and then we're going to talk about parallel and perpendicular again. You'll have an activity on Thursday and Friday that you will fully explore the full extent of linear equations. It should get you ready for your test. I want to talk first about the graph that you see here on the screen. I wanted to just talk in general about the graph, about the changes in this graph. It's kind of a strange looking graph, and we're talking about lines, and you probably are asking yourself, okay, wait a minute, Zorn, I don't see just a line. Well, we have a series of lines here connected, which calls us a piecewise function. It's parts of several lines together, and this happens to be a continuous graph since they are connected. They could be separate, but it's still linear in its nature. So notice first we have from straight across here we have a line with a constant rate of change, and that so it would be a slope, if you wanted to say, of 0, but it is a constant rate of change. Then notice we have a vertical line. A vertical line. And hopefully you know that a vertical line has a undefined slope. An undefined slope. There is no rate of change because there is no change as you move across. It's just staying the same right there. Then we have a positive slope. We have another vertical line, which means an undefined slope. And then we have a negative slope right here. Let's talk next a little bit about intervals. The constant part of this line is on the interval from 0 to 3. So from 0 to 3. There is no change here, so there's no average rate of change, so there really isn't. It's, at 3. From 3 to 5 is where our line is positive, and positive means it's moving upward, so it would be increasing on the interval from 3 to 5, and that's how we would say that. Then, of course, again, we have no change. And then our average rate of change is negative over here. Our slope is negative, and that's on the interval from 5, and we're just going to say the graph stops right there at 8. And so if it's the negative slope, it's moving downward. It would be called decreasing on the interval from 5 to 8. From 5 to 8. So let's just talk a little bit about that one more time. So from the interval from 0 to 3, we have an interval from 3 to 5, and we have the interval from 5 to 8. All right, from 0 to 3, our graph is constant. From 3 to 4, remember there's nothing happening here, but right here this positive slope would mean it was increasing. And from 5 to 8, our slope is decreasing, or our function is decreasing. The next thing I want to talk just a little bit about is slope, or we're going to now call that an average rate of change in an average rate of change, the slope in a linear function. Remember our slope formula we talked about a little bit yesterday, but remember it's y, 2 minus y1 over x2 minus x1, and that is our slope. Or we might write it as delta y over delta x. That's the change in y over the change in x. That could also be our slope. And then we're going to talk about this, and we're going to refer to this as the average rate of change. And that's really important that you say it that way going forward. It's the rate of change over time, and we're actually calculating the average rate of change over time, what's happening on an average. All right, so the next thing we're going to do is we're going to just review our 3 forms of linear equations. We talked about them yesterday. We have point slope, and that is, of course, y minus y1, the given y value, equals the slope and x minus a given x value, or x1. We can also talk about y-intercept form. This is probably the one you're most familiar with, y equals mx plus b. But you're now in pre-cal. We're going to talk about this one more. We're going to go to this form more often, and we can convert that form then, of course, to this. We did that a little bit yesterday. And then finally, standard form, and that will be ax plus by equals C. And again, this can be changed to this form. This can be changed to this form. I'm going to put arrows at both ends. These are all interchangeable forms, but we're going to focus on point slope. All right, let's move on to our second graph and our final graph for the evening. All right, let's take a look at this graph. This is another piecewise function, but it is also linear. We've got 1, 2, 3. There's a 3 right there where the graph changes. At 0, it makes a change. And then down here again at 1, 2, 3, positive 3, it makes another change. And this would be, we'll just say that it's out to infinity over here. Let's just say that this continues. Put a little arrow on the end, and we'll put a little arrow on the end. That'll just help us review a few more skills. So if you go on out to the left forever, of course you'd be moving toward, it'd be negative infinity out here. And if you go out to the right forever, of course you'd be positive infinity over here. So let's first talk about our increasing and our decreasing. I don't see any constant, I don't see any horizontal flat lines, I don't see any vertical lines where there is no decrease or a constant rate of change. So let's just talk about the increasing and decreasing intervals. So our intervals would be from negative infinity to 3. Our interval would be from 3 to 0. From 0 to 3. Oh, that was negative 3, my bad. And then from 3 to positive infinity. All right, so we have 4 intervals. So let's take a look. We're leading from left to right. This graph is, I'm going to take my pen and we're moving down, so that would be decreasing. Then we're moving up, that would be increasing. We're moving down again, that would be decreasing. And then on this interval, we are increasing. So you read the graph from left to right, just like you read most things. All right, let's find the average rate of change. So average rate of change on the interval from negative 3 to 0. From negative 3 to 0. So from negative, we're going to look at, let's change colors here. We're going to look at this graph right here, or this line right here, and take the average rate of change. Now the average rate of change is just the slope. It's not the equation of the line yet. We are going to do that, but let's just take about the average rate of change. I'm going to go old-fashioned on you, and I'm just going to flat out count the slope out. Sometimes when we have a graph, we forget we can just count our slope out if it's got good points, and this one seems to have good points. The next one also has good points, and we could count, but we're going to also try to do it algebraically. So if we counted our slope, would be rise over run. So 1, 2, 3 over 1, 2, 3. So 3 over 3 is 1. So our average rate of change is 1. So our slope in this case is 1. All right, now let's go back and let's take a look. Let's take a look at, let's take a look at the average rate of change on the interval from 0 to 3. From 0 to 3. All right, let's take a look at that interval. That would be right here. I'm going to make it in green. On that interval, the average rate of change there. All right, I really could just count the slope, but I'm not going to do that. I'm actually going to pick this point and this point, and I'm going to actually calculate the average rate of change algebraically. So this ordered pair right here is at 0, 1, 2, 3. So we have an ordered pair of 0, 3. And we have another ordered pair at 3, negative 3. 1, 2, 3, yeah. So 3, negative 3. So let's calculate the average rate of change, and then let's count and make sure that we agree. So the change in y, so that would be, this would be our y2 and our x2. So the change in y would be negative 3 minus 3. Over the change in x, which would be 3 minus 0. Negative 3 minus 3 would be negative 6, and that would be over 3, which would give us a negative 2 over 1. So the slope is negative 2 over 1. Let's see if that works. Let's count. That would be down 2 to the right one. 1, 2, 1. That looks right. And then 1, 2, 1. That would be right. And 1, 2, 1. And that puts us right there. So I believe that's right. The average rate of change is actually a decreasing at a rate of 2. All right. So that takes care of average rate of change. That takes care of which is our slope. Let's now look at writing some equations. All right. Let's write the point slope form of the line on the interval from 0 to 3. So that's that green line. So I'm going to write the equation of the point slope form down again. It's y minus y sub 1 equals slope and x minus x sub 1. All right, so now let's take a look at that. So we're going to say that is y minus, all right, so we got to have a point. We need a point, and we need a slope. Well, we calculated the slope a while ago. We calculated the slope on the interval from 0 to 3 to be -2. So we already know that part. Now we got to pick a point. We can pick any point we want on the line. It does not matter which point you use. It's going to come out the same in the end. So I'm just going to pick this starting point, which is at 0, 3. So let's plug in. Our y value is 3. So we have y minus 3 equals the slope of -2, and we would have x minus 0. All right, so there's our point slope form. Let's change our point slope form into slope intercept form, which is y equals mx plus b. Let's do that. That means we need to isolate y in a minute. To do that, we're going to go ahead and distribute the -2, and so you're going to have -2x, so you're going to have y minus 3 equals -2x, and of course -2 times 0 is just 0, so just -2x. And then we would add the 3 to the other side, and we would get y equals -2x plus 3. Well, that makes sense because this is the slope, and this is the y-intercept in this form. And that's true. There's our y-intercept. We could have picked any point on this line, okay, and it would have come out the same. I want to make sure you know that because there are going to be equations that you come up with where you're not going to pick the y-intercept. You're going to pick another point. You might not even know what the y-intercept, or the y-intercept won't be a pretty point, and you'll need to do that. All right, and then last, let's take let's take this form right here and go ahead and change it to standard. All right, so this standard form we know is ax plus by equals c. So we need the x value to move to this side, so we would have a positive 2x. We would keep the y, and that would equal 3. And there you have standard form, you have slope-intercept form, and you have point-slope form. But I want us to start with point-slope form because we can use any point along the line that we have. Okay, last thing I want us to do is get a little bit of practice on parallel and perpendicular lines. Parallel and perpendicular lines. All right, I'm going to pick a point, and then I'm going to have us use this line right here, and I'm just going to pick a random point. We're just going to say we want a line that's perpendicular to this given line right here, and it goes through the point of, let's just pick 2, 2. That'll make it easy. So 2, 2, and it's perpendicular. I'm going to use a little perpendicular symbol to this line right here. Well, if it's perpendicular, then what do we need? We need the slope, and we need a point to write the equation. If it's perpendicular, it's going to be the opposite reciprocal slope of this line. So it's not going to be -2 over 1. It's going to be positive 1 over 2. So our slope would be positive 1 over 2. So I'm going to plug this back in my point slope formula. There's my point, my x and my y. I'm going back to this form right here. Let me go ahead and write it in another color. Oops, I don't know why that keeps doing that. All right, so when I do that, I am going to write y minus our y value. So y, minus our y value of 2 equals our slope we now found of 1/2 times x minus our x value of 2. Now, there's a couple of things that we can do, and I want to show you this. We can leave it like this if it's point slope. If we wanted in slope intercept form, we could distribute, and this one comes out pretty easy. But I'm going to say let's clear the fraction. Let's clear the fraction. To clear the fraction, I'm going to put this in parentheses, and I'm going to multiply this side by a 2 to get rid of my 1/2. And I'm going to multiply this side by a 2 because I have to do both. Whatever I do to one side of an equation, I have to do to the other side of the equation. So it to be fair and equal, so to speak. So I'm going to distribute the 2 here, so I get 2y minus 4 equals, that's just 1 now, so 1 times x minus 2 is x minus 2. Notice I don't have fractions now. So you always want to clear out your fractions if you don't have a calculator. And then we're going to put it in slope-intercept form. Remember, in the end, my slope should be 1/2 if I do everything correctly. I'm going to add the 4 to the other side, and when I do, I'll get 2y equals x, and I have -2 plus 4, so I have positive 2. And then all of a sudden, I'm going to go divide by 2, divide by 2, divide by 2. And when I do, I'm going to get y equals, that's 1/2. Oh, I'm happy about that, x, plus 2 over 2 is 1. 2 over 2 is 1. And there you go. And you have slope-intercept form. And of course, what we could have done is right here, before we divided by 2, we could have moved the x over and been in standard form. You've got to be really comfortable moving from form to form. We will have a lot of practice on Thursday and Friday, and you are going to go on a fabulous, amazing treasure hunt. Okay, I hope you have a great night, and I will see you tomorrow. Night, Bearcats.